Hello friends, welcome to the session on communication electronics. In this session, we'll be discussing about pulse width modulation and pulse position modulation. In short, we call it as a PWM and PPM. In this session, we will see what we mean by pulse width modulation, and we will see the basic principle of pulse width modulation. Also, we will see what we mean by PPM or pulse position modulation, and we will see the basic principle of pulse position modulation. Friends, as you know that you are viewing this session on my YouTube channel, Learn with Prakash Nade, and subscribe to the channel to see more videos on the subjects of electronics and computer science. So let us go for the discussion of pulse width modulation. In pulse modulation, we know that the modulating signal is a continuous signal, but the carrier signal is in the form of pulses. Pulse width modulation is a technique in which the width of the pulse or time duration of the pulse is being changed in accordance with the amplitude of the modulating signal. Since there is a change in the time duration, you will find that the pulse width modulation is also called as the pulse time modulation. And this technique is very similar to that of frequency modulation. Pulse width modulation is also an analog pulse modulation technique. As we have seen last time, that the pulse amplitude modulation is also an analog modulation technique. Similar to that, pulse width modulation is also analog pulse modulation technique. Pulse width modulation technique is a technique which do not require any synchronization between the transmitter and receiver. In certain pulse modulation technique, you will find that the synchronization between the transmitter and receiver is required, but in PWM, we do not require such synchronization. In pulse width modulation, it is possible that we can easily separate out the noise from the required signal. This is because the amplitude of the pulses is remaining constant and there is only variation in the width, and therefore the noise can be easily separated. Pulse width modulation technique is very powerful technique because it can be used for controlling the analog circuit with a microprocessor's digital output. Pulse width modulation technique can be used in wide variety of applications. Say for example, we can use it in the measurement circuits, and also it is possible that we can use it in communication circuits to control the power. Pulse width modulation technique will require the larger bandwidth than that of PAM. So you can say that this is one of the drawbacks of pulse width modulation. The biggest advantage with the pulse width modulation is that it do not suffer from the noise. PAM technique, as we have seen last time, it will suffer from the noise, but this technique will have a good noise immunity. The required transmitted power in pulse width modulation is more and it is variable. So this is also a kind of drawback of the pulse width modulation. This is because the width of the pulse is continuously changing and therefore the transmitter power will also vary. Now we will go for the basic principle of the pulse width modulation. As shown in this diagram, suppose this is the continuous modulating signal. And when this modulating signal is being coupled to a comparator circuit, then it is possible that we can generate the PWM pulses. Observe that the width of the pulse will go on increasing as the amplitude of modulating signal goes on increasing. The width of the pulse will go on decreasing for the negative amplitude of the incoming modulating signal. Pulse width modulation is a process in which the width of the carrier pulses is being changed in accordance with the amplitude of the modulating signal. Observe that when there is a variation in the width, it means that the amplitude and position of the carrier pulses are kept constant. Pulse width modulation signal can be easily generated by making the use of timer IC 555 in monostable mode. we can apply the carrier pulses through the trigger input, and the modulating signal can be applied to the control input. And when we operate this IC 555 in monostable mode, then such PWM pulses can be easily generated. Pulse width modulation technique works on the principle that whenever a modulating signal or a sawtooth signal and a sawtooth signal is applied to the comparator circuit, then we can generate the pulse width modulation signal. That is, the PWM signal can be easily generated by making the use of comparator circuit, because this comparator circuit will compare between the modulating voltage and the sawtooth voltage, by which it is possible to generate the PWM pulses. Now we will go for the discussion of pulse position modulation. In short, it is called as PPM. Pulse position modulation is a pulse modulation technique in which the position of the carrier pulses is changed in accordance with the amplitude of modulating signal. So here there is a change in the position of the pulses, while the amplitude and the width of the carrier pulses are kept constant. PPM technique is also called as pulse time modulation, and it is similar to the phase modulation. PPM is also an analog modulation technique. So PAM, PWM, and PPM, all three are the analog modulation technique. PPM technique is a technique where we will require the synchronization between the transmitter and the receiver. If there is no synchronization, then this modulation technique will fail. In PPM, it is possible that you can generate the noise, and whenever some noise is being generated, then such noise can be easily separated from the PPM signal, because in PPM signal the amplitude is constant, the width is also constant, and therefore the noise can be easily separated. Pulse position modulation is a very powerful technique, and it is being used for the contactless smart card. So the smart card technology, where no contact is required, such technology can make the use of pulse position modulation. Pulse position modulation is also used in wide variety of applications. Say for example, the radio frequency ID, say for example, it is called as RFID. For RFID tags, this technology is used. This technology will also require larger bandwidth. So PWM, PPM, these techniques will require comparatively larger bandwidth than that of PAM. Another advantage with the PPM is that it do not suffer from the noise, and therefore we can say that this technique has a good noise immunity. Also, in this technique, since the width of the pulse is constant, the amplitude of the pulse is also constant, and therefore the required transmitted power in the PPM is less and it is not variable. In case of PWM, it is variable. So you will find that some of the disadvantages of PM and some of the disadvantages of PWM are eliminated in PPM. Now we will go for the discussion of basic principle of pulse position modulation. As we know that the modulating signal is a continuous signal. Whenever we want to generate the PPM pulses, then initially we will generate the PWM pulses by making the use of comparator circuit. These PWM pulses are differentiated. After differentiation, you will find that it is possible that we can generate the PPM pulses. Pulse position modulation is a process in which the position of the carrier pulses is being changed in accordance with the amplitude of the modulating signal. And therefore, in this technique, amplitude and width of the carrier pulses are kept constant. So whenever you have been asked to generate the PPM pulses, then it is necessary that first of all generate the PWM pulses by making the use of comparator circuit or by making the use of IC 555. These PWM pulses are differentiated by using the differentiator circuit. So whenever these pulses are differentiated, then we will have a positive going narrow pulse for the leading edge, and then we will have a negative going narrow pulse for the trailing edge. So as shown in this diagram, you will find that for the positive edge, one positive going narrow pulse is generated for the leading edge, and for the trailing edge, another negative going narrow pulse is generated for each pulse. The time displacement of the negative going narrow pulses corresponding to the unmodulated pulses is measured, and it is proportional to the amplitude of the modulating voltage. So you will find that all the positive going pulses are eliminated and only negative going pulses are considered, and their time displacement with respect to the carrier pulse is being measured. And you will find that this displacement is proportional to the amplitude of the modulating signal. So when the amplitude is more, the displacement is more, as shown in this diagram. When the amplitude is less, then the displacement is less, as shown in these diagrams. So thank you friends for viewing the session. Hopefully you have understood what we mean by the pulse width modulation and pulse position modulation. In our next session, we will discuss some other techniques from the pulse modulation. Thank you all for